Hey kids, welcome to section 6.4, modeling data. Today we're going to learn how to find equations of best fit for data modeled by exponential and logarithmic functions and how to find the best model for a data set. So a couple of things to talk about first is what an equation of best fit is. So an equation of best fit helps to analyze data patterns between two variables. And the way that we look at this data is by using something called a scatter plot. A scatter plot is one of the tools used to display data and provides information on the relationship between the variables. When you describe the relationship between two variables with a scatter plot, you need to include three things. Comment on the direction. Is the data going in a positive direction or a negative direction? There are examples here, positive on the left and negative on the right. You can also comment on the form of the data. Does it form a generally linear relationship or is it more nonlinear? And then you can comment on also the strength of the relationship. Do the values in the data set form a strong positive correlation where everything is kind of, you can see the line? Is it a weak correlation where you can see that stuff is going in a positive direction but is not very tight? It can be a strong negative where the values form a downward fashion line and they're pretty tight, versus a weak negative correlation where the values are clearly going down but not as tight. And then no correlation is when you just have randomly dots everywhere. Now, once you decide on what the scatter plot data is giving you, you can determine if it's going to fit best into a linear function, quadratic function, exponential function, or power function. Once you figure out what type of regression you have, you can make something called a regression line, which is when you try to fit an equation to the data in the scatter plot. So let's take a look at how we do this. First, let's look at the equations before we look at the data, and let's figure out which equation represents what kind of data set. We can also call it the best model. So if we look at letter A, y equals 2x squared plus 3, the little 2 up in the exponent tells us that a quadratic function is going to be the best. If we look at letter B, y equals 1 half x to the fourth, that fourth power is telling me that we're going to use a power function, which a power function is basically any exponent greater than 2. If we look at letter C, y equals negative 0.4x minus 11, this is written in y equals mx plus b form, so this is a linear function. And letter D, y equals 3.5 to the x. Since the variable is in the exponent, this is an exponential function. Now, it's nice when we have the equation, but what if we just have data? So use a graph to describe the direction, form, and strength of the data set. So we can graph this on a coordinate plane, or we can use the calculator to graph it for us. The next page, just FYI, gives you all the different steps that you need in order to plug stuff into your calculator for a scatter plot. You can follow the directions. But to plug stuff into the scatter plot, one more thing. You need to make sure that your scatter plot is ready to calculate. So you only have to do this one time. You only have to do this again if you reset your calculator or if you use someone else's. But you need to hit second and then 0. And you need to scroll through until you find diagnostics on. So diagnostic on. We only need to do this once. And we're almost there. Diagnostic on. There we go. So we're going to hit enter until the calculator screen says done. That's what the directions say. Okay, so we only have to do that once. So now we can go back, and to enter data into the scatter plot, you're going to go to stat and you're going to hit enter for edit. If there are things in L1 and L2, you can clear them by pressing up, clear down. We're going to take and put the x's into L1. So all of these first values are our x's. So we're going to do -3. We're going to do -2. We're going to do -2.5. And then we're going to do -1. Now the y values are going to go into L2. So we have 0, 2, 1, and 4. Now, once we get the values into our graph, we want to make sure that we can graph. We need to turn the scatter plot on. So we need to hit second y equals and make sure that number 1 says on. Then you also want to make sure that you have the scatter plot chosen, which is the first one. Okay, so now we can exit out of this. And now to graph, we're going to hit zoom 9. There's my 4 dots. It looks quite linear. So I'm going to say, I need to say something about direction, form, and strength. So I'm going to say that it's in a positive direction because the dots are going up, left to right. I'm going to say it's fairly linear because they form a straight line. And I'm going to say, well, they all look very strongly related, so strong correlation. All right, let's try letter B. So we're going to go back to stat, hit enter. We're going to clear the values by hitting up, clear, down, up, clear, down. I'm going to put my x's in 0, 1, 2, and 3. Then go to my y's. 1, 2, 4, and 8. Then hit zoom 9 to see what you get. So as you can see from this picture, it doesn't look like it's a straight line. It definitely is going up and to the right, so it's positive. It's not a linear function, so non-linear. And the dots do form a clear pattern, so this is a strong correlation. All right, let's do letter C. So again, we're going to go back to our stat and our edit. We're going to clear up, clear down, up, clear down. Our x's are the first numbers. Those go into L1. And then our y values go in L2. And then to graph it, I'm going to hit zoom 9. This looks like I got 2 points here, and then it dips, and then it comes back up again. So this is definitely going in the negative direction. It is non-linear. And I'm going to say that this is a weak relationship because the dots are not forming a clear pattern. All right, so here are the instructions again, how to put data into the stat list, how to graph a scatter plot. Now we're going to work on how to calculate a regression equation. Also, take a look in this top right corner. I have different R values. This is your correlation coefficient. If you have a really strong relationship, then you're going to have a number close to -1 or close to +1. So this top one is -1 and it's going down. The bottom middle one is going up and it's pretty tight at a 0.9. This one's almost perfect at a 1.0. And then you have weak correlations, ones that are going in a positive direction but not very tight, ones that are going in a negative direction, not very tight. And then here's when your R equals 0. That's your correlation coefficient where it's very, very weak. Nothing really is going on. So let's take a look and see how we can find the best model given data. So this one says the table shows the cost of a smartphone in different years. Graph the data with X representing the number of years since 2012 and Y representing the cost of a smartphone. Describe the direction, form, and strength of the scatter plot. So it tells me that X is the number of years since 2012. So I'm going to make another column here. So 2012 is 0 years from 2012. 2013 is 1, then 2, then 3, then 4. So when I go over here to my data, I'm going to go to stat and edit. I'm going to clear my data by doing up, clear, down, and up, clear, down. I'm going to type in my x values 0, 1, 2, 3, and 4. My y values are going to be 325.50, 406.88, sorry, 88, 408.60, 635.75, and 794.69. Okay, after I get it in, I zoom 9. So it looks like it's almost forming a straight line, except for this little guy right here. So it looks like it's positive. It doesn't really look linear, so we're going to say nonlinear. And then as terms of strength, well, it doesn't look super strong, so I'm going to say weak. Now, to describe the best model for the data, what we need to do is we need to run a regression function on the calculator to be able to tell which one it is. Now, if you go back to the previous slide, to calculate the regression equations, there are 4 of them. There's linear regression in the form of ax plus b. There's quadratic regression, there's exponential regression, and there's power regression. Those are the 4 types of functions that we talked about at the very beginning of the lesson. We need to run all 4 of them, and then based on the R value, we'll be able to tell which one is the best. So let's do linear regression first. So to do linear regression, we're going to go to stat, and we're going to go to calc, and we're going to choose number 4, lin reg ax plus b, not number 8, but number 4. And then basically we just hit enter a bunch of times. And what we're going to do is we're going to look for the R value. So R equals, and take like the first 3 numbers. So like 0.947. Okay, now we have to run the exponential regression to see what that R value is. So we're going to go to stat, and we're going to go to calc, and we're going to go to exponential regression, which you have to scroll down until you get to number 0, which is exponential regression. We're going to hit enter a bunch of times, and we're going to grab the R value. So R equals 0.964. Ooh, so far exponential is a stronger model than linear. All right, let's go to power. So stat, calc. Sometimes it's quicker to go up from the bottom. There's your power function, power reg. So that's letter A. Hit enter a bunch of times. And we get a correlation value. Oh my gosh, it doesn't work. So therefore, we cannot find a power function. It does not exist. Okay, then we try the quadratic function. So let's exit out of this. Let's try to do stat calc quad regression. So quadratic regression is number 5. Hit enter a bunch of times. Now, the weird thing about quadratic regression is it does not give you an R value, it gives you an R squared. So we have to take the R squared, which is 0.966, and we need to figure out what the R is. And to do that, I'm going to square root what I just copied down for R squared on my calculator. And so I'm going to do, get out of this, I'm going to do second square root. I'm going to type in 0.966, and it's going to give me an R value of 0.983. Well, according to the R values, the quadratic function is the better model because it has the highest exponent. So the best model is going to be quadratic. And now I can actually pull my values off of the calculator. So let's go back to stat, calc, quadratic regression is number 5. Hit enter a bunch of times. And so usually 3 decimals is going to be a good amount. It'll always tell you in the directions how many decimals you should use, but usually, or maybe 1 decimal. We'll go with 1 decimal. So we're going to take a look. It says y equals ax squared plus bx plus c. So my a is 27.2. So 27.2 x squared. My b value, it looks like 8.0. So 8.0x. And my c value is 335.2. There is the best model for the data. All right. Well, we just talked about how to do a regression equation. This graph or this table here just kind of goes over some of the other equations that we've talked about: exponential, growth or decay. We have something called natural exponential function, which is just e to the x. We have the standard form of an exponential function, a to the x. We have the standard forms for logarithmic or natural logarithmic functions. We also have something called changing the base, which we're going to be using off and on throughout the rest of the chapter. So if I'm looking to convert an exponential form to a logarithmic function to solve for x, what I can do is in letter A, 4 to the x equals 262,144. I'm looking for what power of 4 is going to give me 262,144. So what we can do is we can take the log of both sides. So we can do a log of 4 to the x equals, or what I want, scratch that. We're going to use the change of base formula. The change of base formula is used after you change it to a logarithmic function. So I'm going to change this exponential to logarithmic by doing the log base 4 of 262,144 equals x. Remember, 4 to the x equals 262,144, so I can go backwards. Then this left side, I can use the change of base formula. The change of base formula allows me to take something not in base b, or base 10, let's say, and we change it to base 10. See, your calculator only can calculate stuff in base 10. So if it's in base 4, it can't. So we use the change of base, which says you can take the log base 10 of the top number and divide it by log base 10 of the bottom number. So if I type this on my calculator, I use the log button over here on the left side. So log of 262,144. Make sure you close the parentheses before you divide by the log base 4. So this gives me an x equals 9. So 4 to the 9th power gives me 262,144. All right, if we look at letter B, 9 to the x plus 5 equals 6566. Before I do anything, I have to get the exponential part by itself. So I need to subtract 5. 9 to the x equals 6,561. Now I need to change the exponential function to logarithmic. So log base 9 of 6,561 equals x. I can use the change of base formula, which says to take log of the big number, log of 6561, and divide it by log of the base, which is log 9. So if I do this, log of 6561, close the parentheses, divided by log of 9, I get 4. So that means that 9 to the 4th power is 6,561, which is true. If I do letter C, I need to add 47 to both sides before I do anything. 5 to the x equals 291. Then I need to change it to logarithmic form. So log base 5 of 291 equals x. Now I need to change it to exponential, or to change a base formula. So x equals log of 291 divided by log of 5. If I do that, log of 291 divided by log of 5, we get, ooh, this one's a decimal, so nearest hundredth, the directions say, 3.53. So 5 to the 3.53 power equals 291. We can check that. 5 to the 3.53 power. Notice I get 293, so it's pretty close to 291. We could also plug it into the original equation. If I were to subtract 47, I should get 244, and I get something very close. Okay, if I look at letter D, negative 2 to the x power equals 42. So I can change it to logarithmic. Log base negative 2 of 42 equals x. I can use the change of base formula, so I get log of 42 divided by log of negative 2. So log of 42, close your parentheses, divided by log of negative 2. Notice that gives you an error. That's because you cannot take the log of a negative number. It's illegal. Your paper will burst into flames. So this has no solution. All right, that's the end of section 6.4. If you guys have any questions, let me know. And as always, keep calm and keep trucking.